next problem. A 230 volts DC shunt motor is taking 5 amperes when running light. So light means that is under no load condition. So that is under no load condition. It will takes 5 amperes. This is called the I naught. And this is our supply voltage. V is equal to 230 volts. The armature resistance is RA is 0.2 ohms. And the field circuit resistance is 115 for an input current of 72 amperes. So this is one part under no load conditions. For an input current of 72 amperes, this is called the line current is 72. Calculate the shaft output and efficiency. Also calculate the armature current. Yes, IA is equal to how much at efficiency is maximum. So coming to our problem, right? Solution. I naught is the no load current of motor. No load current of motor, that should be equal to 5 amperes. Our supply voltage is 230 volts. The RA is equal to 0.2 ohms. RSH is equal to 115 ohms. And so this is the second part. If the IL is equal to 72 amperes and calculate IA at maximum efficiency. So I naught is equal to IA naught plus ISH. How we can calculate the ISH value? ISH is equal to V divided by RSH for DC shunt motor. 230 divided by 115. So that should be equal to 2 amperes. What is an IA naught? IA naught is equal to I naught minus ISH. The no load current is 5 and the shunt field current is 2. Then IA naught is 3 amperes. Then calculate the no load armature copper loss. No load armature copper loss is equal to IA naught square into RA. That is 3 volt square into the RA value is 0.2. That should be equal to 1.8 watts. And the next one is no load input. What is the no load input? V into I naught. The value is 230 into 5. So 1150 watts. Then you can find the constant losses. The constant losses is equal to no load input minus no load armature copper loss. No load armature copper loss. What is the no load input now? Here it is 1150 minus 1.8. That should be equal to 1148.2 watts. The case 2, if a low line current is 72 amperes, the shunt current is same, that should be equal to 2 amperes. Then IA is equal to IL minus ISH. 72 minus 2, that should be equal to 70 amperes. 70 amperes. The total losses at load. Armature copper loss plus constant losses. The armature copper loss is 980 plus 1148.2. Then I got it as 2128.2 watts. What is the power input at the 72 amperes? V into IL. 230 into 72. Then 16560 watts. That should be equal to 16.56 kilowatts. Power output is equal to power input minus total losses. So 16560 minus 2128.2 Finally I get it as 14.431 watts. So then finally calculate the efficiency of motor. You can remember only one thing: under no load operating condition you can find out the constant losses. After that, if any load is given, calculate the armature copper loss at full load and total losses. Then you will find the efficiency of a motor. 14.431 divided by 16.56 kilowatts, kilo cancelled, then 87.14 percentage, the 87.14 percentage. And at maximum efficiency is very important, the variable losses is equal to constant losses. IA is equal to root of constant losses divided by RA. The constant losses is 1148.2. The armature resistance is 0.2. Then finally I got it as 75.76 amperes. So this is very important problem. And a 500 volts DC shunt machine draws 4 amperes as a motor on no load. If RA is equal to RF is given. Find the constant losses. Efficiency when running as a generator supplying 50 amperes load at 500 volts. And the first one is, as a motor is giving the no load current is 4 amperes, armature resistance is 0.2, and the shunt field winding resistance is equal to 500 ohms. What is ISH? V divided by RSH. Our supply voltage is 500. The RSH is also given as 500. Then the shunt field current is 1. Then IA naught is equal to I naught minus ISH. 4 minus 1, that should be equal to 3 amperes. Then you should find out the no load armature copper loss is equal to IA naught square into RA. So 1.8 watts, 3 square into 0.2, 3 square into 0.2, then you will get the 1.8 watts. After that you should find out the field copper loss. This is one of the constant losses. ISH square into RSH, that should be equal to 500 watts. Then you can find out the constant losses. Constant losses is equal to no load input minus no load armature copper loss. What is the no load input? V into I naught. No load armature copper loss is IA naught square into RA. The no load input I got it as 500 into 4, that is 2000. IA naught square into RA is 1.8. Then finally I got it as 1198.2 watts. And the second bit is, as a generator is asking, as a generator, the terminal voltage is now 500 volts and the load current is 50 amperes. What is the output power now? So VT into IL, so 25 kilowatts. Is there any change in the shunt current? The shunt current is constant, VT by RSH, that should be equal to 1 ampere only. Here IA is equal to IL plus ISH, 50 plus 1, 51 ampere. And what is the armature copper loss now? IA square RA is equal to 51 whole square into 0.2, 520.2 watts. Then calculate the efficiency of generator. Output power divided by output power plus losses. So we are calculate the armature copper losses, and constant losses will be same. That should be equal to 1998.2 watts. Substitute here 25 into 10 to the power of 3 divided by 25 into 10 to the power of 3 plus 1998.2 plus 520.2 into 100 is equal to 90.84 percentage. This is the efficiency of generator. Okay, so these are the model problems are important in an university point of view.